Hello students, welcome to our video lesson number 3, Curved Mirrors Ray Diagram Part 1. So in this part, I am going to show you the 3 special rays that we will be using in order to complete a ray diagram. And in Part 2, I will be showing you how to actually use those 3 rays to complete a ray diagram. So Part 1, we need to understand the 3 special rays that are going to help us. Which ones are those rays? Okay, so I do have a curved mirror here. Until and unless I draw those dashed lines, I will not be able to say whether it's a concave or a convex mirror. Now I want it to be a concave, so I'm going to draw the dashed lines on the outside of the cave, making it a concave mirror. The geometric center is my vertex V, and I am going to draw the principal axis passing through the vertex and the center of curvature somewhere over here. But this is my principal axis. Remember to always use a ruler to draw your ray diagrams and a very pointed, sharpened pencil to draw these diagrams. Otherwise, your ray diagrams will not turn out to be as expected. And remember, eventually we will be using these to find out the height of images and the distance of the images from the vertex as well. So use rulers and a sharpened pencil. So my principal axis is drawn. Now again, imagine this this curved part being sliced away from a larger sphere. So if that's my sphere, which I'm not going to completely draw in this diagram, somewhere over here will be my center of curvature. Looks like it's in the center of this imaginary circle over here. And my focal point will be halfway between C and V. So my ruler is rather broken here from the corner, but that's okay. I'm going to manage. This distance between C and V is 4.5 centimeters. So half of that would be 2.25, so 1 centimeter, 2 centimeter, and another 0.25. So this is my focal point represented by F. Okay. Now remember that we always use an upright arrow to represent our objects. It could be any object placed in front of my mirror. Okay. The object could be placed anywhere in front of the mirror. Depending upon where the object is, the characteristics of the image will then change. Let's just say that the object for our purposes is placed somewhere between C and F. Okay, so I'm going to represent my object with an arrow. The arrowhead representing the top of the object, and the bottom of the object represented by the tail of the arrow, which is always placed on the principal axis. The tail of the object or the arrow is placed on the principal axis, and the top is away from the principal axis. Now remember that we are going to be studying 3 special rays, which will help us in drawing the ray diagrams. Ray number 1. This ray travels from the top of the object towards the mirror, staying parallel to the principal axis. Okay, now even before we go into the details, we need to understand that the entire object reflects rays in all different directions. Okay, there are rays coming out in this direction, this direction, this one, this one, this one, this one, this one, all the directions around the three-dimensional space around the top of the object. We are going to be considering just 3 of all those millions of rays. Okay, and we are right now also considering just the rays being reflected from the top of the object. Remember, each and every part of the object does reflect rays, and that is why we are able to see the object. But to understand how to draw ray diagrams, we are going to simplify the whole situations. We are only considering the top of the object which is reflecting the rays, and of all those rays we will narrow it down to our 3 special rays. So the first ray is the one that I'll be drawing using the red pen. This is the ray that goes from the top of the object towards the mirror, and the ray stays parallel to the principal axis. So let's draw that incident ray going from the object towards the mirror. Now remember, a ray diagram is incomplete if you do not show these arrows. This arrow actually tells me that the ray moves from the top of the object towards the mirror. At this point, the ray is going to be reflected. It's not going to go through because it's a mirror. It will be reflected. It will reflect so that it passes through the focal point after reflection. So let's draw the reflected ray now. After it hits the mirror here, it reflects in a way that it passes through the focal point. So draw your reflected ray, extend it longer, because you will need that extended ray later. This time the arrow is facing away from the mirror, representing this as the reflected ray. So that is our ray 1. It started off going parallel to the principal axis. It went towards the mirror. It hits the mirror, gets reflected, and the reflected ray then passes through the focal point and carries on in straight lines. That is our ray number 1. Ray number 2, which is our second special ray, is actually the ray that passes towards the mirror after having crossed the focal point. So again, the top of the object emits rays in all directions. There's one ray definitely that will be emitted in a direction towards the mirror, but it goes through the focal point. So draw the incident ray going from the top of the object towards the mirror. So that's my direction over here. Now this ray, which has come to the mirror after having passed through the focal point, will get reflected in a way that it goes parallel to the principal axis. So let me draw the reflected ray for the blue one that came from the focal point and gets reflected out of the mirror, going parallel to the principal axis. Now be really careful in drawing this ray exactly parallel to the principal axis. Okay, so you draw that ray. Okay. Draw it longer so that it actually intersects your first ray, the red one. Now you understand why you needed to extend the red line from ray 1. Okay, and since it's a reflected ray, you put the arrow over here. Okay. This point where the two reflected rays meet is the point of interest, because that is where the image of the top of the object will be formed. However, keep that in mind. You will need to know that when you do part 2 of this same lesson. Okay, so we went through ray 1 represented in red, ray 2 in blue. There is one more special ray which you might not need very often, but there are a few cases where you will actually need that ray. Okay? This is the ray that I'm going to draw in orange. Okay? So this is the ray that actually it travels towards the mirror, but it's also the ray that falls in line with the center of curvature. So again, there are so many rays emitted by the top of the object. There is one ray that would travel towards the mirror, but it's also in line with the center of curvature. Okay, let's draw that ray. I think I will have to extend my mirror a little bit, so let's do that. Okay, that's good. I didn't need the bottom portion, but just to maintain the symmetry. Okay, so take your ruler and you're trying to draw the ray from the top to the mirror, but also it falls in line with the center of curvature. So this is my third ray. Okay, the third incident ray going towards the mirror. So draw the arrow going towards the mirror. Now this ray, this incident ray that hits the mirror through the center of curvature will actually reflect so that it will retrace its own path. So after being reflected off of the mirror, this ray will not travel in any other direction. It will actually retrace its own path. Okay, so you take your ruler, place it so that it aligns with your incident ray, and because it retraces its own path, it will come out so that it passes through the center of curvature. This is your third ray. Okay, now ideally, this ray should actually pass through the same point of intersection, but it does not, because I have not been able to draw this diagram very perfectly, and the reason for that is I am right now sitting down with my broken ankle elevated in the air, and I am not in the right position to draw the ray diagrams. Anyways, so for right now we need to understand these three rays. The first one, the red one, going parallel to the principal axis, reflects through the focal point. The second one goes towards the mirror through the focal point, comes out parallel to the principal axis. And the third one goes towards the mirror in line with the center of curvature. It retraces its path. So these are our three special rays that you will use in order to construct ray diagrams for different object positions in front of the mirror. Okay, so just a little note here. Ray 1, special ray 1. Incident parallel to principal axis. Reflects through. Okay, let me continue over here. The incident ray parallel to principal axis, it reflects through the focal point. Ray number 2, incident through focus, and reflects out parallel to principal axis. This sign here means parallel. Reflects parallel to principal axis. Ray 3, which you will not use as much as ray 1 and 2, but it's good to know about it. Incident ray through center of curvature. Reflects also through center of curvature. Okay, so this is part 1 for our curved mirror ray diagrams. Remember how these 3 rays originate, how they hit the mirror, and how they reflect. In our part 2, we will be using these rays to construct ray diagrams for various positions of the object in front of the mirror. And depending upon where you're placing the object, the image will change.